Hello everyone, welcome to today's session. Today we are going to learn about total internal reflection, TIR. Look at this simple demonstration. You can see a coin placed at the bottom of an empty glass. Now the coin is easily visible. All of you can see the coin through the glass. The glass is empty. Now let's check it out. What happens when water is poured into the glass? Now let us pour some water into the glass. Yeah, what you can see? The coin is no more visible. The coin has disappeared when water is poured into the glass. What is the reason behind this? What is the scientific phenomenon responsible for disappearing of the coin? Let's check it out. It is known as total internal reflection. Well, dear students, we have seen the simple demo in which a coin placed at the bottom of an empty glass disappears when water is poured into the glass. And the scientific phenomenon behind the disappearing of the coin is total internal reflection. Now we will try to give a theoretical explanation for total internal reflection. What is total internal reflection, TIR? How does it take place? What are the essential conditions for the total internal reflection to take place? Let's check it out. Now, let us consider the case of refraction taking place from a denser medium to rarer medium. The same thing we have studied in the previous session also. If you haven't watched the video, please watch the video and learn about critical angle, the concept of critical angle. Okay, let's have a fast recap. You can see when light travels from rarer to denser medium, at all angle of incidence, a part of is being reflected and a part of light being refracted at the surface of separation between glass and air. You can see the both reflection and refraction take place simultaneously. All right. Now it was happening for a small angle of incidence. Now gradually you increase the angle of incidence. What you can see shown by the red light rays, the angle of refraction going on increasing. As you increase the angle of incidence, angle of refraction going on increasing, and refraction and reflection taking place at an angle lesser than the critical angle. Now what happens? Now if you increase the angle of incidence, now you keep on increasing the angle of incidence at a particular value of angle of incidence, you can see that the corresponding angle of refraction in the rarer medium is 90 degree, such that the rays of light are traveling along the periphery. We call it as gradual emergence. So at this particular value of angle of incidence in the denser medium corresponding to the angle of refraction in the rarer medium is 90. We call it as critical angle. We call it as critical angle. We have studied in the previous session. So here in this case, when the angle of incidence is equal to critical angle, you can see the ray of light is emerging along the periphery, along the boundary between glass and air. All right. So when angle of incidence is equal to critical angle, the rays of light is emerging through the boundary. All right. Now in the third case, this is the first case, second case, and in the third case, what will happen if we increase the angle of incidence beyond critical angle, more than the critical angle? What will happen? Now you are increasing the angle of incidence beyond critical angle. Now angle of incidence is more than the critical angle. What will happen? Instead of getting refracted along the periphery, the light ray will bounce back to the same denser medium. You can see that the light ray is getting back to the same medium, or bouncing back to the same medium. So the bouncing back of the light to the same denser medium, we call it as reflection. Okay, now it is found that the whole light energy, the whole intensity of the light is being reflected back to the same medium. That's why it is call it as total internal reflection, TIR. So at a particular angle of incidence greater than the critical angle for the pair of media glass and air, you can see the whole light energy, the whole intensity of the light is getting reflected back to the same denser medium. So it is known as total internal reflection. Why it is called total internal reflection? You can see that it is coming back to the same medium. So it is known as striking a surface glass air interface. So it is known as reflection. Why it is called total internal reflection? It has been experimentally found that the whole energy, the whole intensity of the light is getting reflected back to the same medium. That's why it is known as total internal reflection. All right. So the total internal reflection is nothing but it's a special case of reflection at which when the angle of incidence is greater than the critical angle, the whole light rays are getting reflected back to the same medium. And this phenomenon is known as total internal reflection. So what are the conditions essential for total internal reflection to take place? The total internal reflection will not take place at any time. When certain conditions are observed, this particular phenomenon will take place. So what are the conditions for the total internal reflection to take place? Observe this. We can conclude the light ray must travel from you can see denser medium from glass to air, from denser to rarer medium, and one first important condition. So what is another condition? The angle of incidence, you can see the angle of incidence should be greater than critical angle. When the angle of incidence is greater than critical angle, only then the TIR will take place. Otherwise what will happen? For angle of incidence less than critical angle, partial refraction and reflection will take place at the boundary of this pair of media. When angle of incidence is equal to critical angle, the grazing emergence will take place, that is light ray will pass along the boundary, and when the angle of incidence is greater than the critical angle, TIR will take place. So remember the two conditions essential for TIR to take place. So what is total internal reflection? Define total internal reflection, and what are the conditions essential for TIR to take place? These are two important questions for the board examination point of view. Okay. So in this process of TIR, as I told you, 100% energy is or intensity of light is reflected back into the same medium. No other device, you know that reflection is taking place in case of a mirror also. So in case of a mirror, some light energy is being absorbed there. The whole light is not being reflected when it is striking a mirror. So when a ray of light is striking a mirror, it is getting reflected back to the same medium, such that angle of incidence is equal to angle of reflection. So but in case of reflection taking place on the mirror, the whole energy is not getting reflected back to the same medium. Some loss of energy is taking place here. But in case of total internal reflection, no loss of energy. 100% energy of light is reflected back into the same medium. No other device such as plane mirror produces 100% reflection. So TIR, this phenomenon is used in case of periscope, binocular, and in case of some camera, we take the help of total internal reflection, because total internal reflection, 100% energy is reflected back to the same medium, and we get a very clear, brighter image. All right, is it clear? Fine. So what is total internal reflection? What are the conditions essential for total internal reflections? Okay. Now if you compare the total internal reflection with the plane reflection, how can you compare the total internal reflection with the plane reflection? In case of total internal reflection, you can see that the total energy is getting reflected back to the same medium. But in case of normal reflection, some part of the energy is lost. Alright, that's one difference. The entire light is getting reflected back in case of TIR, but in case of normal reflection, only a part of is getting reflected back. There is no loss of energy in case of TIR, and there is some loss of energy in case of plane reflection or normal reflection. So these are the differences between normal reflection and total internal reflection. Please note it. Once again, I will repeat. In case of total internal reflection, when light passes from denser medium to rarer medium, okay, the total internal reflection takes place, but it takes place when light is incident on a plane mirror from a medium, any angle of incidence. For any angle of incidence, light ray is incidenting on the mirror. For any angle of incidence, the normal reflection takes place. The entire light is getting reflected back. In this case of normal reflection, only a part of light is getting reflected. There is no loss of energy in case of TIR, but in case of normal reflection, there is a loss of energy is taking place in case of normal reflection. So differentiate between TIR and normal reflection is also a board question. Please remember the answer. Alright, is it clear to you? Thank you. Okay, fine. We have seen what is total internal reflection. What is total internal reflection? How does it take place? What are the essential conditions for TIR to take place? Now, as a concluding part, based on our theory, what we have learned in this session, we will try to explain our simple demonstration. Okay, so in the simple demonstration, we have seen that an empty glass, a coin was placed at the bottom of the glass, and when the glass was empty, you could see the coin very easily, right? So in this case, normal refraction in empty glass taking place. You can see that a coin is placed here at the bottom of the glass, and the ray of light is traveling from rarer medium to denser medium, and again it is emerging from glass to again rarer medium. So it is getting refracted, and the refracted ray is striking at the glass air interface at an angle of incidence less than the critical angle, such that it is getting refracted out, and the refracted ray is reaching the eyes of an observer, and the observer can see the coin very easily. That's what we have witnessed in the demonstration. Okay, in this case, when the angle of incidence is less than the critical angle, simple refraction, normal refraction takes place, and the coin was visible. Now, in the second case, consider the second case. The glass is filled with water. When water is poured into the glass, the coin disappeared, right? You have seen that the coin disappeared. So how can you explain this? So consider this case. The glass is full of water. Now a coin is placed at the bottom of the glass. A ray of light is traveling from rarer medium to denser medium. It is getting refracted, and it is getting refracted through the water filled inside the glass, and this refracted ray is striking the glass water air interface at an angle greater than the critical angle. So when the angle is greater than the critical angle, angle of incidence is greater than the critical angle, what happens? The rays is, instead of getting refracted, you can see that it is getting totally internally reflected. It is getting reflected back to the same medium, and as a result, no light rays reaching the eyes of an observer, and the coin is no more visible. Coin disappeared. So there is no magic behind that. It is simple. It happens because of total internal reflections. In this way, we can give explanation to our demonstration based on the theory we learned about total internal reflection. Thank you very much.